So we're going to start talking about scatter plots. Now, we've been graphing linear equations and discussing what those look like. We've talked about all three different forms of linear equations. And a scatter plot is not going to be a linear equation. A scatter plot is going to display the relationship I teach math. Relationship between two sets of numerical data. Okay, so which is what we usually have even when we graph a linear equation. And what this is going to do is not going to be in a straight line, but it will show trends within our data. So an example of a scatter plot might be it's going to have a bunch of dots, so it's going to be, So for example, if we were to pass a book down a line or do the wave and time ourselves, then we could maybe compare the number of students to the time in seconds. So you can see here that depending on how many students are in the line, it's going to take a different amount of time, but that may not be a completely straight line. So scatter plots are going to be discrete data. That means that it's going to be dots. We're not going to connect them. Now, what we can do is we can look for a trend. So we can see here that as the number of students goes up, the time goes up. So the trend here is going to be a positive trend because both of them are increasing. We sometimes can also have a negative trend. So let's say the number of hours you play video games and your test score. So here you can see that this is going to be a negative trend. It is still discrete, okay, because as the number of hours goes up, your test score goes down, okay. Sometimes we have absolutely no relationship at all. Okay, so maybe your color of your hair and your shoe size. One does not have any relationship to the other. So this is a no trend or no correlation or no relationship because there's nothing going on. There's nothing connected. Now, sometimes when we have, I'm going to go back to this very first one with number of students and time. Sometimes when we have a scatter plot, we can draw what we call a trend line or a line of best fit, which is kind of like an estimation line. So where you're just kind of trying to find the average. So I'm trying to go, maybe I hit 1 or 2 dots and I've got about the same number on both sides. And what we can do with this, when we'll look at this tomorrow with the calculator, is we can pick a couple of coordinates that fall on that line, and then we could write that equation. And what that equation is going to represent is the average for that situation. So we can draw a trend line aka line of best fit. And we can use our calculator, and we're going to talk about that tomorrow, like we did with point to point, where we can put some coordinates in and it's going to give us an equation that we can then use to estimate and predict. So what I'm going to ask you to do is we're going to look at an example here. I'm going to pull in, this is page 196 from your book. And I want to do a couple of examples with you using real data. So number 15 says create a scatter plot of the data using days absent as the independent variable. Remember, independent is going to be X. So you can do this in your margin. You can do this in your journal. So we have days absent. Make sure you label, and your grade as a percent. And I'm looking at it goes up to 6, so maybe I just do my scale by ones. And it looks like we're going from 69 to 98, so maybe I go from 65 to 100. Now I'm going to do a graph break here. If you remember, we talked about that a couple years ago, and that's where we're not going to start right at 0 because otherwise we have all this extra space. 85, 90, 95, 100. So my scale is actually 5s there, even though I only labeled every other one. So when we do our scatter plot, so 0 days absent, you have probably a 98. Let me make this a little bit bigger. Okay. 3 is an 88, and we're just estimating here. You have grid lines on your paper, might be a little bit easier. 6 is a 69. 1 is an 89. 2 is a 90. 86. And it's okay. This is not representing a function. We have 2 of the same x values, but that's okay because it's just a scatter plot. 77 for 4. All right, so you can see this is what our scatter plot looks like. Is the data linear? Well, no. It does not create an exact straight line, so no, it is not linear. Explain using the scatter point. Okay, so exactly that. So we can say no for 16, not a line. Based on the data, how do the grades change as the number of absent days increases? Well, we can see that it is going down. So we could say as the number of absent days increases, the grades decrease. So days goes up, grade goes down. So that means, based on what we talked about earlier, this is a negative trend. Draw a trend line on your scatter plot. So again, that is going to be our kind of estimate line. You can use that 98 if you like. I've got about 3 on both sides. I'm hitting 2 of them. Identify 2 points. So I happened to hit 0, 98. And what is that? 477. Now, it wants us to write the equation. We can write the equation for this because we can use point slope form. So I could find my slope, 0, 98, and 477. So 21 and 4. Oh, that is such an ugly number. We're just going to estimate because it's an estimate line. So we're going to say slope is about 5 and my y-intercept is 98. So I could write y equals, and it's a negative because it's going down, right? negative 5x plus 98. Because it's just an estimate, x and y variables in the equation, so x is going to be our days absent, and y is going to be our grade. Interpret the meaning of the slope and the y-intercept. So it means it goes, grade goes down 5 points each day absent. And then we can use our equation for day 5. So we can say negative 5 times 5 plus 98. So essentially 98 minus 25. So we would say about a 73. So tomorrow when you come to class, we're going to talk about how to write this equation with our calculator. We're going to talk more about our different types of correlation and our lines of best fit. Have a great night.